The horse, a truly magnificent creature. We see them in fields, powerful and graceful. We see them in stories, brave and loyal companions. But have you ever wondered where these animals came from? Their story is not a short one. It is a journey that stretches back millions of years. It is a tale of change, of survival, and of incredible adaptation. This is the story of the evolution of the horse, a journey through the vastness of deep time. We will explore how these animals transformed. The evolution of the horse is one of nature's most remarkable stories. It provides us with a wonderfully clear window. A window into how life itself can change, how it can adapt to new challenges. Over countless generations, horses have altered their bodies. They have changed their behavior, all to survive in a world that was itself constantly changing. Humans have a special connection with horses. We have worked with them for thousands of years. Understanding their past helps us appreciate them even more. Imagine a world very different from our own, a world that existed 55 million years ago. This is where the horse's story begins. The first ancestors of the horse were not large and powerful. They were small creatures, perhaps the size of a small dog. They lived in dense forests, very different from the open plains where we often see horses today. Their journey from these ancient forests to the modern grasslands is truly astonishing. It is a testament to the power of evolution. In this exploration, we will travel back in time. We will meet these early horse ancestors. We will see how they lived. We will learn about the pressures that shaped them. We will look at the key stages in their development, how their toes changed, how their teeth adapted, how their bodies grew. It is a fascinating detective story. The clues are found in fossils, buried deep within the earth. Join me as we uncover the galloping history of the horse. Our story begins in a very old time, the Eocene epoch. This was around 55 million years ago. In the warm, damp forests of North America and Europe, a small animal lived. This creature was one of the very first ancestors of the modern horse, scientists call it, but it is perhaps better known by its more evocative name. This name means dawn horse. It was truly the dawn of the horse lineage, a tiny spark of what was to come. What did this Eohippus look like? It was certainly not like the horses we know. It was a small animal, only about 20 to 60 centimeters tall at the shoulder. That is about the size of a fox, or perhaps a small terrier. It had an arched back, quite different from the straight back of a modern horse. Its neck was short and its snout was also relatively short. It would have looked quite delicate, moving quietly through the undergrowth. It was a creature perfectly suited to its forest home. Now let's look at its feet. Eohippus did not have hooves like modern horses. Instead, it had toes. On its front feet, it had 4 small toes. On its back feet, it had 3 toes. Each toe ended in a tiny individual hoof-like nail. These toes were spread out, and the feet had pads, much like a dog's paw. These padded, multi-toed feet were ideal for walking on the soft, uneven ground of the forest floor. They helped the Eohippus move quietly and securely. And what did Eohippus eat? It lived in lush, subtropical forests, so its diet consisted of soft leaves, fruits, and berries. It was a browser, not a grazer like modern horses. Its teeth were small and simple. They were suited for crushing soft plant material. They were not yet ready for tough grasses. Eohippus was a gentle creature of the ancient forests. It was a humble beginning for such a magnificent line of animals, a small, quiet step on a very long evolutionary path. The world in which Eohippus lived did not stay the same. Our planet is always changing. During the Eocene epoch, the Earth was generally warm and very wet. Vast forests covered much of the land. These forests were the perfect home for small creatures like Eohippus. They provided food and shelter. They offered protection from creatures that might want to eat them. Life was, for a time, quite stable for these early horse ancestors in their leafy homes. However, over millions of years, the Earth's climate began to shift. It started to become cooler and drier. This change was very gradual, but it had a huge impact on the environment. As the climate changed, the vast, dense forests began to shrink. In their place, new types of landscapes started to appear. Open woodlands and, crucially, vast expanses of grassland began to spread across the continents. This was a dramatic transformation of the world's ecosystems. This change in the environment presented a great challenge for the early horses. The soft leaves and fruits they were used to eating became harder to find as forests receded. The new expanding grasslands offered a different kind of food grass, but grass is tough. It is much harder to chew and digest than soft forest foliage. The open plains also meant fewer places to hide from predators. Life was becoming more exposed, more demanding for these evolving animals, so the early horses faced a critical choice: adapt or disappear. Survival depended on their ability to change. They needed to find ways to live in these new open environments. They needed to be able to eat the new types of food available. This pressure to adapt was the driving force behind their evolution. It set them on a path of remarkable transformation, a path from small forest dwellers to the larger, swifter animals of the plains. Living on the open plains brought new dangers. In the dense forest, Eohippus could hide from predators among the trees and bushes, but on the wide open grasslands there were few places to conceal oneself. For an animal that was prey, this was a serious problem. The best way to survive in such an environment was to be able to spot danger from afar and, crucially, to be able to run away very, very quickly. Speed became essential for survival. In response to this need for speed, the bodies of these evolving horses began to change. Their legs started to grow longer and more slender. Longer legs meant longer strides, which in turn meant faster running. Imagine the advantage this gave them. A horse that could run just a little bit faster than its neighbor was more likely to escape a predator. It was more likely to survive and pass on its genes for longer legs to its offspring. Body size also began to increase, albeit slowly at first. The feet of these early horses also underwent significant transformation. Remember Eohippus with its 4 front toes and 3 back toes. As horses moved onto harder ground and needed to run faster, the structure of their feet began to adapt. The central toe on both front and back feet started to become larger and stronger. It began to bear more of the animal's weight. The side toes, in contrast, started to become smaller and less important. This was the very beginning of the development of the single hoof. At the same time, their teeth were also changing. Grass, the new dominant food source, is very abrasive. It contains tiny particles of silica, like sand, which can wear down teeth quickly. The small, simple teeth of Eohippus were not suited for this tough diet. So the teeth of evolving horses began to grow larger. They developed more complex ridges and harder enamel. This made them much better at grinding the tough grasses of the plains. These adaptations were vital for their new way of life. Section 5. Middle evolutionary milestones: Mesohippus and Miohippus. About 35 million years ago, during the Oligocene epoch, a new character appeared in our story. This was Mesohippus, which means middle horse. As its name suggests, it was an intermediate stage in horse evolution. Mesohippus was a bit larger than Eohippus. It stood around 60 centimeters tall, perhaps the size of a modern greyhound. Its back was less arched than Eohippus. Its face, neck and legs were all a little longer. It was starting to look more horse-like. A key difference was in its feet. Mesohippus had 3 toes on both its front and back feet. The 4th toe on the front foot, seen in Eohippus, had disappeared. The middle toe of the 3 was now clearly larger and stronger than the 2 side toes. It bore most of the animal's weight. However, Mesohippus still walked on pads like its ancestors. These side toes likely helped it to walk on soft ground, providing some extra stability. The teeth of Mesohippus were also more advanced. It had more molars, the grinding teeth at the back of the mouth, than Eohippus. These teeth had higher crests, making them better suited for chewing tougher vegetation. Mesohippus lived in a world where forests were still common, but grasslands were continuing to expand. It was likely browsing on leaves, but also starting to include some tougher plants in its diet. It was a creature of transition, adapting to a changing menu. Slightly later, around 32 million years ago, another important horse ancestor emerged, called Miohippus. This name means lesser horse, though it was actually a little larger than Mesohippus. It was also more varied. Some species of Miohippus continued to live in forests, while others ventured further out into the developing plains. This branching out shows that evolution is not always a simple, straight line. Sometimes different populations adapt in different ways to different environments. Miohippus represents this diversification. Section 6. The rise of grasslands and grazing, Merychippus, the true grazer. The Miocene epoch, which began around 23 million years ago, was a time of dramatic change. Grasslands, which had been gradually expanding, now truly began to dominate vast areas of the earth. These grassy plains created a whole new world of opportunity for animals that could adapt to them. For the ancestors of the horse, this was a pivotal moment. The ability to thrive on a diet of grass became paramount. This period saw the emergence of a truly revolutionary horse ancestor. This ancestor was, which means ruminant horse, although it didn't actually ruminate like a cow. It appeared around 17 million years ago. Merychippus was a significant step closer to the modern horse. It was much larger than its predecessors, some species reaching the size of a small pony, about 1 meter tall at the shoulder. Its longer legs and more rigid backbone made it a more efficient runner on the open plains. It was built for speed and endurance. The most striking changes in Merychippus were in its teeth. Its teeth were dramatically different from those of earlier horses. They were much longer or high-crowned. They also had a thick coating of cement, a hard substance that helped to protect them from wear. These teeth grew continuously from the jaw to replace the surfaces worn down by chewing tough, gritty grasses. Merychippus was a true grazer. It could effectively grind down large quantities of grass, its primary food source. Remarkably, Merychippus stood primarily on its middle toe. The two side toes were still present, but they were much smaller. They were splints that did not touch the ground except perhaps when running on soft terrain. It was effectively walking and running on the tip of its greatly enlarged central toe on each foot. This was a crucial development towards the single hoof. Merychippus also had a sophisticated system of ligaments in its lower legs that acted like springs, helping it to run more efficiently. Section 7. One toe to rule them all, Pliohippus and the single hoof. The evolutionary journey towards a single powerful hoof continued relentlessly. After Merychippus, the next major player on the stage was. This horse ancestor lived during the Pliocene epoch, roughly between 5 and 12 million years ago. Pliohippus represents another significant leap towards the modern horse. It was becoming even better adapted to life on the vast open grasslands of North America, where many of these evolutionary changes were taking place. It was a creature truly shaped by the plains. Pliohippus is often celebrated as the first truly one-toed horse. While Merychippus still had small visible side toes, in Pliohippus these side toes were even further reduced. They became mere splint bones, thin slivers of bone running alongside the main cannon bone in the lower leg. They were no longer functional for walking or running. They did not touch the ground at all. All the animal's weight was supported by the very large, strong central toe on each foot. This single central toe had now fully developed into a true hoof. A hoof is essentially a greatly enlarged and thickened toenail. This solid, curved structure provided excellent traction on hard ground. It protected the toe from impact and wear. The single hoof, combined with long, slender legs and powerful muscles, made Pliohippus an incredibly efficient runner. It could cover long distances at speed, essential for finding fresh grazing and for escaping predators like saber-toothed cats. In terms of its overall appearance, Pliohippus looked very much like a modern horse, although it was generally a bit smaller. It had a similar body shape, a long neck and a horse-like head. Its teeth were also very similar to those of modern horses, high-crowned and well-suited for grinding tough grasses. Pliohippus was a highly successful animal. It roamed the plains of North America in large herds, a testament to the effectiveness of its evolutionary adaptations. Section 8 equus the modern horse arrives on the scene, and so, after tens of millions of years of gradual change, we arrive at the genus. This is the group that includes all modern horses as well as donkeys and zebras. The first members of the genus appeared around 4 million years ago during the Pliocene epoch. They evolved from ancestors like Pliohippus in North America. The arrival marks the culmination of that long evolutionary journey we have been tracing. These were animals superbly adapted to life on the plains. The horses of the genus were generally larger than their predecessors. They possessed all the key characteristics that define modern horses. They had long, powerful legs, each ending in a single, strong hoof. Their teeth were perfectly designed for a life of grazing on tough, abrasive grasses. They had high crowns and complex grinding surfaces, allowing them to process their food efficiently. Their bodies were built for speed and stamina, crucial for survival in open environments. They also had a deep chest, which housed large lungs. This provided them with the excellent cardiovascular capacity needed for sustained running, whether to escape danger or to migrate across vast distances in search of food and water. Their senses were highly developed. They had keen eyesight, with eyes positioned on the sides of their head to give a wide field of vision. Their hearing was acute, with ears that could swivel to pick up sounds from all directions. These were vigilant, athletic animals. From their origins in North America, horses spread far and wide. They crossed the Bering Land Bridge into Asia. From Asia, they migrated into Europe and Africa. They also moved south into South America. For a time, horses were incredibly successful across much of the globe. Then a strange event occurred. Around 10 to 12,000 years ago, horses, along with many other large mammals, disappeared from North and South America. The reasons are still debated, but climate change and human hunting likely played roles. Horses would only return to the Americas with European explorers many thousands of years later. Section 9. Conclusion, a magnificent testament to adaptation. The story of the horse's evolution is, by any measure, truly amazing. It is a journey that spans an immense period of time, more than 55 million years. We have traveled from a tiny, shy creature of the ancient forests, the Eohippus. We've seen it transform step by step into the large, powerful and graceful animal that we know and admire today. This long and winding path showcases the incredible power and patience of nature. It is a story written in stone in the fossil record. Every change we have observed in the number of toes, the structure of teeth, the size of the body, the length of the legs, was a direct response to a changing world. As forests gave way to grasslands, as new food sources appeared, and as new dangers emerged, the horse lineage adapted. This remarkable ability to change, to evolve, is the key to survival for all life on Earth. The horse provides one of the clearest and most complete examples of this fundamental biological process. The fossil record of horse evolution is exceptionally rich. Scientists have unearthed thousands of fossils from different time periods. These fossils allow us to piece together the story with remarkable detail. We can see the gradual transitions from one form to another. It is like watching a very, very slow-motion film of life unfolding. This detailed record makes the horse a classic textbook example of evolution in action, studied by students and scientists all over the world. Today, horses share a unique and enduring bond with humankind. We have relied on them for transport, for agriculture, for sport, and for companionship. This long evolutionary journey, driven by the forces of nature, has shaped them into the resilient, intelligent, and athletic animals they are. Their story is more than just a scientific account. It is a source of wonder, a magnificent testament to the adaptability of life and the enduring beauty of the natural world.